Hi everyone. In this video we're going to continue on with section 6.4, which has to do with logarithmic functions. And so in this video we're actually going to talk about a certain part of a logarithmic function, and actually in the last video we talked about logarithmic equations. Now we're going to look at functions, which of course are slightly different. Okay? We're going to look at a certain aspect of logarithmic functions that are important, and that specific aspect is its domain. So, to start with, recall that we have the definition of a logarithmic equation is that y equals log base a of x, if and only if x is equal to a to the y. Okay? And so, this definition shows us that logarithmic functions are actually the inverses of its corresponding exponential function. And because they're inverses, that gives us certain information about the domain and range of a logarithmic function. Okay? And so if you'll recall, the domain and the range of an inverse function, although we didn't talk about this too much, so maybe it's not a recall, it's here's some new information. The domain of the inverse function becomes the range of the regular function, and the range of the inverse function becomes the domain of the regular function. So they switch. Your domain and range switch for the inverse version. And so if we remember, for exponential equations, the range of an exponential function, function, the range of an exponential function was 0 to infinity. And so that becomes the domain of a logarithmic function, a basic logarithmic function, log base a of x, 0 to infinity. The domain of an exponential function was negative infinity to infinity. That becomes the range of the logarithmic function. Okay? And so they switch. That information can help us find the domain of a logarithmic function, of course. Okay? And so I have three examples here. One is easy, two are more challenging, about finding the domain of a logarithmic function that's been transformed somehow. Okay? And so because for the base logarithmic function, log base a of x, let's say y equals log base a of x, the domain is 0 to infinity, which means whatever's inside of the parentheses here, that must be positive. It must be positive because the domain, what we can plug in or substitute in, is positive numbers. So whatever's inside of the parentheses must be positive. Okay? So that's going to help us here in the future, in what we're doing right here. And so I'll call this 1, 2, and 3. All right, let's look at number 1 first. I want to find the domain of log base 2 of x plus 3. So in order to find the domain, we simply have to solve the inequality x plus 3 is greater than 0. Okay, so we subtract 3 from both sides, and we get that x is greater than negative 3. So the domain of this function is negative 3 to infinity. Pretty simple. If you look and think about the function graphically, we have that you're adding 3 to x, and so that corresponds to a horizontal shift to the left of 3. And so if I have a function where the domain is 0 to infinity and I shift left 3, that means the new domain is negative 3 to infinity. Okay? So that's number 1. That's an easy one. Number 2 is actually quite a bit trickier. Okay? And so you can expect something like this maybe on the homework, but probably not on the exam. I have log base 5 of 1 plus x over 1 minus x has to be greater than 0. That's the function log base 5 of 1 plus x over 1 minus x. So the domain are the values for which 1 plus x over 1 minus x are greater than 0. Okay, and so this takes a little bit of thought, and the usual way that you would think about solving this problem, which would be trying to get x alone, is not quite going to work how you would think it is. So I need to think about, rather than trying to solve this, I think it might be more helpful to think about possible values of x and what would work. Okay? So, if you think about things, this equation has to be, or this expression here, has to be positive. We could think about random values on a number line that would make that work. And so you could start with something like maybe, I'll start near 0, maybe like -3. Okay? And if you substitute in -3, you'd get 1 minus 3, which would be -2, divided by 1 minus, actually it would be 1 plus 3, 4. So it would be -2 over 4, -1/2, that's not greater than 0. Okay, and so anything more than -3 is not going to work. If we try -2, that's 1 minus 2, -1 over 3, that's still not. What about -1? If we substitute -1 in there, you get 1 minus 1, which is 0, over 1 plus 1, which is 2. That's almost true. So then you have 0 divided by 2, which is 0. 0 is equal to 0, but it's not greater than. So -1 doesn't work. But if I'd plug in or substitute in anything else negative, like anything towards 0, it would work. Okay, -1 doesn't work, but anything between 0 and -1 would work. And so that is valid. So the domain starts at -1. So if we do the domain here, it starts at -1, but isn't where -1 isn't included. If I plug something like 0 into the expression, 1 plus 0 is 1, and then 1 minus 0 is 1, so I'd get 1 divided by 1, which is 1. That is greater than 0, so 0 works. And then we could go all the way up and try a next value, which is 1. Okay? And if I substitute in 1, something interesting happens, because if you look in the denominator, I have 1 minus x. So it would be 1 minus 1 equals, that would equal 0, and it would be 2 over 0, and I can't divide by 0. So 1 is not included. So everything up to 1 is included, but 1 is not. So let's go up to 2 then and see if 2 works. So maybe it's just that 1 is a weird point, but everything else would work. If we try to substitute in 2, we get 1 plus 2, which is 3, and then we have 1 minus 2. That gives us a -1, which makes it a negative number, and so 2 doesn't work. Thus, what we have is that the domain has to be between -1 and 1, non-inclusive. Okay, so I know that was a much tougher problem. Another way to think about this problem is if the fraction has to be greater than 0, what that means is that both the top and the bottom have to be greater than 0. So I could set both of them to be greater than 0, and then I could solve them. And I could see where the 2 overlap. So if I solved the top inequality, I'd get x has to be greater than -1. Okay? So let me rewrite this. Take away the second inequality. 1 plus x has to be greater than 0. That means that x has to be greater than -1. So that gets my starting point of -1 there. And then it's also true that 1 minus x has to be greater than 0. And so if I solve that, I add x, and I get that 1 is greater than x, which means that x has to be less than 1. So what numbers are greater than -1 and less than 1? Well, that's numbers between -1 and 1. Okay? So that was number 2. Domain is -1 to 1. I know that was a little tricky. Again, something that you might expect on the homework, but not necessarily on an exam. Okay? And then if we look at number 3, we have another interesting one. Log base 1/2 of the absolute value of x. Okay? The base of 1/2 could be is an interesting part, but it's not really relevant here. What I care about is the absolute value of x. Okay? And so I have to see when the absolute value of x is greater than 0. And so I have to think, what numbers make the absolute value of x greater than 0? And it turns out that every number except for 1 satisfies this inequality. Because no matter how large a negative number that you substitute into this expression, the absolute value makes it positive. There's only one number that makes this inequality not true, and that is the number 0. So if I plug in 0, the absolute value of 0 is 0. So it's not, in fact, true that 0 is greater than 0. So the domain of this function, or when the absolute value of x is greater than 0, is from, so the domain here is -infinity to 0 and 0 to infinity. Okay, and there's a u in the middle that represents union. You could also put a comma there. I don't care. It's all real numbers except for 0. Okay, so now for the end of this video and for your turn, I want you to find the domain of the logarithmic function log base 5 of 2x plus 7. I guess I should have a y equals here. Okay, but that's the task for you for this video. Okay, I'll see you next time.